Good evening, all of you. Today we are going to discuss grand test paper number 6. That is on complete syllabus. Now, go through the first question. Which of the following is not a unit of time? Which of the following quantities are not is equal to the unit of time? So here, light year. This is not a unit of time. So this is for distance only. Next, burn and shake. So which of these two are not unit of time? So burn is also not unit of time. So that A and B are correct. So go through the second option. Next one. Here C equivalent for parallel circuit is C1 plus C2. Now C1 is given like this, C2 is given like this. Now calculate C1 and C2 are equivalent circuit. C equivalent can be written as C1 plus C2. Now add these two. That means 30 plus 50, 80. And here approximation 2 and here 3, 1. So you have to add those two also. 2 plus 1, nothing but 3. So answer is 80 plus or minus 3. So 80 plus or minus 3. Third option is the correct one. Next one. So velocity is given. Velocity is given as 2t cube in a straight line. Then average speed. So average speed formula V average equal to total displacement by total time, or x2 minus x1 by t2 minus t1. So average velocity formula is total displacement by total time. Now, so here velocity is given, not displacement. Now to calculate velocity, you have to integrate. So velocity can be written as dx by dt equal to 2 into t cube. So dx equal to 2t cube into dt. Now integrate on both sides. Then x equal to 2 into t power 4 by 4. That equal to x equal to t power 4 by 2. This is the position at any time t. Now substitute the values here. So from this one, position at t equal to 0, position at t equal to 3. Let it be x3. x3 equal to 3 power 4 by 2. So 3 power 4 by 2. 3 power 4 means 81 by 2. So x0 equal to 0. Now substitute that one. So 81 by 2 minus 0 by 3 minus 0. 81 by 2 into 3. So in this one 27 times. So 27 by 2. 13.5. 13.5 meter per second is the answer. Direct substitution. Next. For a projectile projected from horizontal surface, the ratio of range to the maximum height. So ratio of range to the maximum height. Range R equal to 4h tan theta. Now from this one, range to the maximum height ratio is equal to 4 tan theta. So R equal to 4 tan theta. First option. Next one. So this is a rod of mass M and length L is moving between perpendicular smooth walls at an angle theta with horizontal. Then velocity of the end A is, so that is nothing but so for this one velocity we have to calculate. So that is if you solve this one by using Newton's laws, then you will get V cot theta. Next one. If a force constant, if a constant force is applied on a body at rest, a constant force is applied. So force formula from Newton's second law, MA or dP by dt or M into dV by dt. So these are the formulas for force. Now, so velocity of the body is constant. No, velocity should be velocity need to change. So that this is incorrect. Next, speed of the body should be constant. So we cannot say exactly. So speed in circular motion speed is constant, but velocity is changing in that case. Next, momentum of the body will be constant. Here, change in momentum by change in time. That means the momentum should be changed. So third option is incorrect. Then the rate of change of velocity will be constant. Rate of change of velocity will be constant. If rate of change of velocity is constant, then force is also constant. So we can go through the fourth option. Next one. So here is the block of mass 10 kg. A force F is applied that is making an angle 30 degrees. So coefficient of friction is given as 0.4. Now what we have to calculate? Frictional force acting on the block. Now here what are the forces acting on this one? This side normal force and F sin theta also this side only. Next weight mg acts downwards. So in this direction frictional force that equal to mu into normal force. So these are the forces acting on this one. So normal force F sin theta, weight mg and frictional force acts like this. Now, so frictional force, what is the value of frictional force? Frictional force is mu into normal force. Mu into normal force. That means F equal to mu into, from this diagram normal force equal to mg minus F sin theta. So this is the one category to calculate frictional force. Now, if it is not moving, so here that is kept on the rough surface, which force F is acting on that one, and the frictional force that is at rest. Block is at rest. So that is the main condition. Block is at rest. So if the block is at rest, then we can consider applied force as a frictional force if applied force is less than the static frictional force. So if applied force is less than this frictional force, then we can consider frictional force as a applied force. Now what is the force applied in this direction? That is F cos theta or F cos 30. So that we can consider this one as F cos 30. Frictional force should be equal to F cos 30. Now component of this force along this frictional opposite to the frictional direction is F cos 30. So that we can take F cos 30 as a frictional force. When we need to take that one? If applied force is if frictional force is greater and applied force is lesser, then you can consider like this. So F into cos 30 root 3 by 2. So F root 3 by 2. Third half. Next. Given that mass of the earth is m, its radius is r. A body is dropped from height equal to the radius. Height above the surface of the earth is equal to radius of the earth. Then when it reaches the ground, its velocity will be. So assume that this is earth surface. So from this height h equal to r, body is released. Now this is the initial one. After that, body reaches the surface of the earth. So initial condition, final condition. Assume that this is a earth of mass m. Here also earth of mass m. So initially body of mass small m is at a height h. So after that, that reaches the earth surface. Now apply law of conservation of energy for this one and for this one also. So here what is the total energy? Total energy. Kinetic energy is 0 because this is at rest. So only potential energy minus G m by r plus h equal to, here both potential energy and kinetic energy will be there. Half mv square minus gmm by r only. So because potential can be written as potential energy can be written as minus gmm by r. So r is the distance between center to center. So center of the earth to the center of the object. So this is total energy at initial position. This is the total energy at a final position. Now solve that equation, then you will get the answer. So what we have to calculate? Velocity we have to calculate. So cancel small m on both sides. Then minus gm by r plus h equal to r only. So r plus r equal to 1 by 2 into v square minus gm by r. So 1 by 2 into v square equal to gm by r minus gm by 2r. So 1 by 2 v square equal to gm by 2r, or v square equal to 2gm by 2 get cancelled out, then gm by r is v square. Then v equal to square root gm by r. Second half. So apply law of conservation of energy. Next one. Two balls of equal masses, 4 kg each, moving with velocity 4 meter per second towards each other, collides inelastically with a coefficient of restitution 0.5. Then loss in kinetic energy due to the collision. So here we need to calculate loss in kinetic energy. So what is the formula for loss in kinetic energy? That is equal to 1/2 into m1 m2 by m1 plus m2 into u relative whole square into 1 minus e square. So loss in energy equal to 1/2 m1 m2 by m1 plus m2 into u relative u square relative whole square into 1 minus e square. Now substitute the values 1/2. So what is the mass of the first one and second one? Same, both are same. 4 into 4 by 4 plus 4 into relative velocity. Both are traveling in opposite direction towards each other. So that relative velocity is we need to add those two. 4 plus 4, that equal to 8 whole square minus 1 minus e value 0.5 whole square means 0.25. Now solve this one further, then you will get the answer as 48 joules. So cancel similar terms, then you will get the answer as 48 joules. Next one. A force of F equal to I j k Newton acts on a point at 2i 2j 2k, and the torque of the force about the point R2. Now position vector R can be written as R2 minus R1. So difference between these two, minus I minus j minus k. So difference between these two is this much. Now for force is given as I plus j plus k. Both are similar vectors, na? So that means the direction is different, exactly opposite. Minus sign is the difference, exactly opposite to each other. So if vectors are exactly opposite to each other or the same direction, and then the torque will be 0. Or just calculate the torque. So R cross F. So I j k, R value minus 1 minus 1 minus 1. F value 1 1 1. So I into so here R is nothing but R2 minus R1, that equal to minus I minus j minus k, and force equal to I plus j plus k. Now torque is nothing but R bar cross F bar. So torque equal to I j k minus 1 minus 1 minus 1 1 1 1. Now I into minus 1 into 1 minus 1 minus of minus 1. So this is equal to plus 1 minus j into close this one and cross multiply minus 1 plus 1 plus k into minus 1 plus 1. Then this is equal to this is a torque. So you will get it as 0. You will get a 0 as the answer. So both are. So same notation, just a negative sign is different. So if equal vectors are opposite vectors are there, then torque will be 0. No need to calculate also. Next, question number 11. A uniform rod of length 3 meter, mass 1 kg is free to rotate vertically about a fixed point. That rod is released from rest in the horizontal position, then initial acceleration is. So here forces are at this location, weight mg acts. Now what is the distance between these two? L by 2. Now basic condition torque equal to I alpha. What is the value of torque? Mg into L by 2 equal to moment of inertia about this position is ml square by 3 into alpha. Just solve for alpha. So cancel m on both sides and 1 L on both sides. Then this is a 3g by 2 2L equal to alpha. Now, what is the L value? L value 3 meter. Substitute that. So 3g by 2 into 3 equal to alpha. So 3 get cancelled out, then g by 2 is the answer. Next, variation of gravitational potential V for a uniform solid sphere of mass capital M and radius R with the distance. So here variation of gravitational potential. So with the distance from center. So that is given by this graph. So within the object, potential is not constant. So that no need to take this one. This is for zero potential. It indicates potential is directly proportional. It indicates within the object potential is constant. So these three are wrong. So that you have to go with the third option. Next. So which of the among following have maximum elasticity? So maximum elasticity. This is nothing but steel. Steel having maximum elasticity or Young's modulus. Young's modulus is more for steel. So our more elastic is steel only, not rubber. So generally you are going to select rubber, but not that is not correct. Steel is the correct answer. Now, 14th. When a load of 1 kg hang from a wire, then extension 2 mm produced, then energy stored in the rod. So energy stored equal to, so 1 by 2 into stress into strain into volume. Substitute the values. 1 by 2 into stress can be written as mg by area. Next, strain change in length by initial length. Volume area into length. Now cancel area into length here. Then 1 by 2 into mg into delta L. That equal to 1 by 2 into m value 1, g value 10, delta value 2 mm means 2 into 10 power minus 3. Then cancel 2. Then you will get 10 power minus 2 joules, or 10 into 10 power minus 3 joules, 10 millijoules. 10 power minus 2 joules or 10 millijoules is the answer. Go with first option. So from this one, 10 into 10 power minus 3 joules or 10 millijoules. Next one, question number 15. A liquid distributed by a stirring comes to rest after some time is due to. So beyond force, no. Stability, no. Surface tension, no. So viscous force. Viscosity is same as a friction concept in mechanics. So due to viscous force only, fluids comes to rest. If you disturb the fluid, then that is going to comes to rest after some time. That is due to frictional force or viscous force. Next one. A plane is in level flight at constant speed. Each of its wing has area 10 meters square. So area is given. If the speed of air on upper end and lower end of the surface are 80 meter per second and 70 meter per second respectively, then mass of the plane is. So from Bernoulli's equation, we can write pressure plus half rho v square v1 square equal to pressure P2 plus half rho into v2 square. So if height neglected or width of the wing is very less compared to the height, so just I am removing the height term. Now here in this for pressure difference, P1 minus P2 can be written as 1 by 2 into rho into v2 square minus v1 square. P2 minus P1 equal to 1 by 2 into rho into v2 square minus v1 square. Substitute the values and solve. So pressure difference can be written as force by area. Force mg by area equal to 1 by 2 into rho into v2 square minus v1 square. But each wing need to lift half of the mass only, so that we need to write m by 2. So here major calculation mistake you will get, because here he said that each wing area is given, so that each wing need to specify or need to lift half of the weight only, half of the weight of the aeroplane only. So that we need to write mg by 2, not mg. So take care of that one. Then substitute and solve. Then you will get the answer. What you have to calculate? Mass only. Rearrange this. So from this equation, from this one, mass can be written as m equal to, so 2 get cancelled out, rho into a into v2 square minus v1 square by g. Now m equal to, so density is given as 1 and g is also 10. So 1 into area 10 into v2 square, that means 80 whole square. So 6400 minus 70 whole square, 4900 by g value 10. How much it is? 64. 10 we get cancel out. 64 minus 49. That is around 1500. So go with the second option. Directly you can remember, in the case of aeroplane wing or upthrust or pressure difference between the wings, only this is the formula. Pressure difference equal to half rho into v2 square minus v1 square. Now if you want to write this one in terms of force, write it as a force by area. Write it as force by area. Next one. An ammeter 5 ohm resistance can read 5 milliampere. So if it is to be used to read 100 volt, then how much resistance should be connected in series? Series resistance. That means, so if a galvanometer connected resistance in series, that is called shunt resistance. Now, in this case, current is same. Series resistance means current is same. Now, so across this one voltage is given. This is a voltmeter. Across this circuit, voltage is given as 100 volt. Now we need to calculate S value. G is given as galvanometer resistance is 5 ohms. G equal to 5 ohm. Next, current I equal to 5 milliampere. That means 5 into 10 power minus 3 ampere. So V is there, I is there, G is there, and we need to calculate for S. So from this diagram, V can be written as V equal to G into I plus S into I. Now take ratio, V by I can be written as G plus S. So S equal to V by I minus G. So what is V by I? V value 100, I value 5 milliampere. That means 5 into 10 power minus 3 minus G value 5. So how much it is? So 20,000 minus 5 is equal to 19,995 ohms. 19,995 ohms. Go with the fourth option. So this can be a voltmeter concept. Galvanometer converted into voltmeter. That concept is this one. So what is the formula? You can write this formula directly also. Shunt resistance equal to V by I minus G. If you remember that one, write like that. Otherwise, you have to write a total voltage equal to voltage across galvanometer plus voltage across shunt resistance. Next, which of the following figure represents a electric field due to a single point positive charge? For positive charge, the electric field line should be away from that positive charge. So first option is the correct one. So he is asking about electric field line only. Next one. If V average is the average speed and Vrms is the root mean speed of the molecule of an ideal gas, then ratio of V average by Vrms. Now what is the formula for V average by Vrms? Just go with formula, just directly substitution only, direct substitution only. Vrms by V average by Vrms. V average by Vrms equal to square root 8 RT by pi m. So Vrms square root 3 RT by m. So let it be capital M. So how much it is? RT by M will cancel out. Now, so what is the remaining? So 8 by 3 pi. Next. So pressure, the pressure in a monoatomic gas increases from P0 to 3P0. Volume from V0 to 2V0. Now the increase in internal energy. So internal energy, change in internal energy formula, NCV delta T. But here we don't know about CV. So which gas is that one? Just monoatomic gas. What about change in temperature? Change in temperature not given. So rewrite this one in terms of pressure and volume. NCV delta T can be written as so P2 V2 minus P1 V1. PV equal to nRT. No? So we can write like this also. Can I write like that? Check it once. So first substitute CV value. After that, go with that one. First substitute CV value. What is the value of CV? 3 by 2 R into delta T. Now 3 by 2 into NR delta T. So NR delta T can be written as P2 V2 minus P1 V1. PV equal to nRT. Na? So change in pressure equal to change in temperature. We can write change in pressure into volume equal to NR delta T. Now substitute P2 V2 value. Final P2, that is 3P0. 3 by 2 into final pressure 3P0. Initial final volume 2V0 minus the initial pressure P0. Initial volume V0. So how much it is? So 3 into 2, 6. 6 minus 1, 5. 3 by 2 into 5 P0 V0. That equal to 1.5. 1.5 into 5. 7.5. P0 V0. Go with second option. Just I am writing PV equal to nRT. So instead of nRT, I am writing a P2 V2 minus P1 V1. Next one. An object in a simple harmonic motion takes 0.250 seconds to move it from equilibrium position to maximum displacement. So from here to here. So how much time that is taking? 0.25 seconds. This is equal to 1/4 of the time period. So one time period means that need to move like this, and need to comes back. After that reverse side, opposite side. After that again comes to same position. So for this one time period T. So if you divide it into 4 parts, T by 4, this one T by 4, this one T by 4, this one T by 4. Now, so T by 4 is 0.25 seconds. Then T equal to 4 into 0.25. That equal to 1 second. This is the time period. Now, what we have to calculate? Maximum velocity, Vmax. Vmax formula, A omega. So, what is the amplitude of the motion? 5 centimeter. 5 centimeter. Omega 2 pi by T. Substitute T value also. That means 10 pi by T value 1 or 10 pi centimeter per second. Both options. Next one. The wave is described by the equation y equal to 0.25 meter sine 5 pi into x minus pi into t. Now, so here this 5 pi is nothing but k, and pi is nothing but omega. Now, what we have to calculate? Speed of the wave, wave velocity or wave speed. Formula omega by k. Omega value pi, k value 5 pi. That equal to 1 by 5 or 0.2 meter per second. Second option. Next one. So for nitrogen, Cp minus Cv equal to some constant x is given. For argon also y is given. Cp minus Cv is always R only. Na? For any gas, irrespective of the gas, Cp minus Cv value is R only. So that x equal to y you have to select. So is it depends on gas properties? No. Cp minus Cv is R, that is for any gas. For diatomic, for monoatomic or triatomic also same only. So x equal to y. Next, 2 point charges, 2 microcoulomb and 18 microcoulomb are separated by some distance 6 centimeter. Then neutral point is, assume that let it be Q1. Q1 equal to 2 microcoulomb. Next, here let it be Q2 that equal to some 18 microcoulomb. So assume that at this location neutral point is there, that is at a distance x from this charge, first charge Q1. Now what is the remaining distance? Distance between these two is 6. Na? So remaining distance is 6 minus x. Now, so at this location or at this point P, neutral point means electric field due to first charge, let it be E1, should be equal to electric field due to second charge. Neutral means electric field should be equal and opposite. Then only you will get neutral point or a zero field point. Now substitute the values k into q1 by, so distance is x square. Here k into q2 by distance 6 minus x whole square. Then q1 by x square equal to q2 by 6 minus x whole square. Now here in this one, q1 value, q2 value. Substitute the q1, q2 values also. That is 2 by x square equal to 18 by 6 minus x whole square. So 9 times cross multiply. 6 minus x equal to 9x square. 6 minus x whole square equal to 9x square. Now take square root on both sides. Then 6 minus x equal to 3x. Then 6 equal to 4x. Then x equal to 6 by 4. That equal to 3 by 2 centimeters or 1.5 centimeter. So 1.5 centimeter from charge x means that is from charge q1. 1.5 centimeter from q1 or 2 microcoulomb. 1.5 centimeter from 2 microcoulomb. Is the option is there? No. So go with other one. If it is 1.5, now from 18 microcoulomb, how much is the distance? 6 minus x. Na? 6 minus x. That means 6 minus 1.5. How much it is? 4.5 centimeter. So either 4.5 centimeter from this charge or 1.5 from 1.5 centimeter from this charge. You have to take either option. So which option is there? 4.5 centimeter from 18 microcoulomb charge is there. So go with that option. Next. So this is a direct formula only. Electric field at a point A is perpendicular direction of a dipole point P for a short electric dipole at an angle theta is. So for this one, theta equal to tan inverse 2 only. Direct formula, tan inverse root 2 only. Tan inverse root 2. For tan theta equal to root 2. Next one. Work done by an external force to carry a point charge Q0 from A to B on the same equipotential surface. So if a charge is moved through equipotential surface, then work done is 0. Because work done formula, work done equal to Q into V2 minus V1. Equipotential surface means potential is same, V2 equal to V1. So Q into V2 minus V2 or 0. So work done is 0 in this case. Next, 27. In the circuit shown in the figure, the charge is stored in the capacitor of 30 microfarad. So these three are in series, na? So that same charge will be there on each and every capacitor. Now calculate equivalent resistance, equivalent capacitance. C equivalent are so these are in series. So C equivalent equal to 1 by C1 plus 1 by C2 plus 1 by C3. Substitute and solve. Then 1 by C equivalent can be written as 1 by 15 plus 1 by 30 plus 1 by 90. Now what is the LCM? 90 is the LCM. So 6 plus 3 plus 1, that equal to 1 by 10 by 90. This is 1 by C equivalent. C equivalent equal to 9 microfarad. So charge Q equal to C equivalent into V. So C equivalent is 9, potential is 40. So how much it is? 360 micro coulomb. This is the answer. So why I am taking same charge? Because all these are in series, so that charge on first capacitor equal to charge on second one equal to charge on third one. 15 microcoulombs aina, microfarad aina, 30 micro aina, 90 microfarad aina, ide charge on. So ye capacitor aina ade charge. Even series lo unnai kada. So go with first half. Next, binding energy per nucleon is highest for iron only. Fe. Next, the current carrying square loop has an edge of length 1 meter. Then magnetic field at center of the loop is magnetic field at center of the loop. So for a square loop magnetic field formula 2√2 into mu naught into I by pi into side length. This is the formula for magnetic field at center of a square loop. 2√2 into mu naught I by pi into A. So side length, what is the A value? 1 meter here. So that substitute 1 meter here. 2√2 into mu naught into I by pi. So this is a magnetic field at the center of the square loop. Next one. Magnetic lines of force inside the bar magnet. So for a bar magnet, what is the direction of magnetic field line? North to south. That is outside the bar magnet, but inside that is from south to north. Inside is that should be south to north. Outside means north to south. So he is asking about inside the bar magnet. So from south to north. Inside is from south to north. Outside is from north to south. For any bar magnet, that is valid. Next, magnetic flux through a circuit of resistance 10 ohms is charged from 20 Weber to 30 Weber in 5 milliseconds. Then charge is. So induced EMF formula. So N into d phi by dt if n number of times are there. So if n number of times not there, then d phi by dt or this can be written as directly flux is given. This can be written as phi 2 minus phi 1 by time taken. This is EMF. EMF can be written as I into R. Now what we have to calculate? Charge. So rewrite current in terms of charge. I equal to Q by T. Q by T into R equal to phi 2 minus phi 1 by T. Now cancel time on both sides. Now from this one Q can be written as phi 2 minus phi 1 by R. Substitute the values. 30 minus 20 by R value 10. So 10 by 10, that equal to 1 coulomb. Second half. So from this equation we can conclude that induced charge is independent of time. That is theoretical important one. Induced charge is independent of time. That is a theoretical question, important one. Next. So capacitor resistor are connected in series across AC supply. So for capacitor, which one is leading? For a capacitor, which one is leading? Current or voltage? Based on that one, we can finalize this one. For a pure capacitive circuit, which one is leading? Current or voltage? current or voltage? Current is leading. So current is leading the potential. So current leading graphs are first graph, second graph. So in third, second and fourth, voltage leading. So here voltage leads means voltage in front of the current. Here also voltage is in front of the current. Voltage leads here. So for these two graphs, current is leading now. So what is the phase difference between current and voltage? That is less than 90. So if it is pure capacitor, that should be 90. Because but here capacitor and resistor is there, so that you will get 0 to 90, between 0 to 90 degrees phase angle, not exact 90. So if it is pure capacitor, then exact 90 is there. So we need to select first option as the correct one. Here exact 90 degrees is there between current and voltage. You can select this one for pure capacitor only, but not a capacitor and resistance circuit. Pure capacitor circuit అయితే 90 ఉంటుంది. ఇక్కడ capacitor resistance ఉంది కాబట్టి less than 90 తీసుకోవాలి. So first option. Next, the direction of EM wave propagation symbols. So according to the EM wave, what is the direction of EM wave? Direction of EM wave should be perpendicular to the both electric and magnetic fields, so that we can select that equation. For direction, we are using V equal to E cross B, just for directions, not for magnitudes. For directions, we are using this formula. So go with the fourth option. That is perpendicular to the E and B. E cross B is the value. Next one. A light of frequency 5 into 10 power 14 Hz travels through a glass with a refractive index 1.5. Then wavelength of the light is. So he is asking about a wavelength. So frequency is there, refractive index is there, but wavelength is asking. So V equal to F lambda. From this equation, we have to solve. What about velocity? So velocity in a medium can be written as C by mu equal to F lambda. Velocity of the wave in a particular medium is C by mu. C value 3 into 10 power 8. Mu value 1.5. Frequency 5 into 10 power 14. Wavelength you have to calculate. Now wavelength can be written as, so here 2 times 2 into 10 power 8 by 5 into 10 power 14. That equal to 0.4 into 10 power minus 6. Or 4 into 10 power minus 7. Or 4000 into 10 power minus 10. 10 power minus 10 means angstroms. 4000 angstroms. Fourth option. 2 by 5, 0.4. 10 power 8, 10 power 14, 10 power minus 6. So 4 into 10 power minus 7. So if you want to write in terms of 10 power minus 10, so other 3 zeros I need to add. So 10 power 10, that becomes a 10 power minus 7 becomes 10 power minus 10. So our 4000 angstroms. Next question. A combination of convex and concave lens placed in contact has a power 4D. If the magnitude of the focal length of concave lens is 100 centimeter, then power of the convex lens is. So power is nothing but power equal to, if they are placed in contact, then power equal to P1 plus P2 plus P3 and so on. If n number of lenses are placed in contact, you have to add power, each and individual powers. Now, what is the first one? Concave lens. What is the total power? 4D. So 4D. Now, so concave lens focal length is given. So concave means minus 100 centimeter. You have to take minus or minus 1 meter. Then power of the first lens can be written as 1 by F1 or 1 diopter. Minus 1. Because focal length is minus 1. So minus 1 diopter plus P2. Now here in this one, P2 equal to 4 plus 1. That equal to 5 diopter. So this is also one important model for calculation. Next one. resolving power of a maximum microscope is maximum power. So resolving power is inversely proportional to wavelength. Resolving power is inversely proportional to wavelength. For less wavelength, resolving power is more. So among these four, which one having a lower wavelength? Blue light. WebGR na order. WebGR. So the wavelength smaller to the larger one, WebGR is the order. So from that one, blue light having small wavelength, so that resolving power is more for blue light. Next. So intensity of the center of the screen in YDSC Young's double slit experiment is 8 I0. Now, if one of the slit is covered, then intensity at center will be. So in this case, generally 4 I0 is the intensity. If I0, if you are taking I0 as the intensity, then maximum intensity is 4 I0. Now here, intensity at center of the Young's double slit is given as 8 I0. Now, one of the slit is covered, then what is the value of intensity? So for I0, 4 I0 you will get. Now here we are getting 8 I0. We are getting 8 I0. Now, what is the value of take ratio? I0 by I equal to 1 by 2. So I equal to 2 I0. So this is a general one. If I0 is the intensity of individual light, then 4 I0 is the intensity at a central maximum. 4 I0 is the intensity. Now, here 8 I0 is the intensity. We don't know the intensity of the individual light. So we need to get 8 I0. So let it be I. Now take ratio between these two. I0 by 4 I0 by 8 I0, that is 1 by 2. So I equal to 2 I0. So 2 I0 is the answer. Next, 38. The light of wavelength 200 nanometer falls on a photosensitive metallic surface whose work function is 4.2 electron volts. Then stopping potential is. So direct substitution only. So Hc by lambda equal to work function plus EV0. So substitute the value. Hc value 12400 by 200 nanometer. So nanometer means here we need to substitute in angstroms. So I am replacing 200 with 2000. Why? Because it should be in angstroms. Remember that. Don't substitute 200 directly. You have to substitute with extra 10 or 2000. So what is phi naught? Phi naught you have to calculate. Phi naught is given as 4.2. So 4.2 plus EV0. Now cancel similar terms. 2 zeros will cancel out, then 6.2. 6.2 equal to 4.2 plus EV0. Now EV0 equal to 2 electron volts or V0 equal to 2 volt. 2 volt. Third option. Next one. A hydrogen atom in a ground state is excited monochromatic radiation of wavelength 975 angstroms. Then number of spectral lines in the emission spectrum. So wavelength you got it as 975. First we have to calculate n value. So n value. N value means so order. So in which state that is there? From which state that is coming to the ground state? Or so if you know the n, then number of spectral lines are equal to n into n minus 1 by 2. This is the formula for number of spectral lines emitted by that due to the transition from n state to different states. Now how to calculate n value? So wavelength is there. Now from this one calculate energy. E equal to Hc by lambda. Hc value 12400 by lambda is 9750. So angstroms, so no need to write this zero. So that is directly in Angstrom. So 975. Now cancel this one. So around 1000. So how many times? So more than 12, na? So nearly 16 times. So nearly 12.7 to 12.7 times. So energy difference. So energy difference means for ground state energy is 13.6. For nth state 13.6 by n square. Now solve this one further. 13.6 into 1 minus 1 by n square equal to 12.7. Now cross multiply. 1 minus 1 by n square equal to 12.72 by 13.6. Now solve for n. Solve for n. Now from this one n equal to how much you will get? Can you calculate? So n equal to 4 you will get. Or from this one you have to solve. So take this 13.6 to this side, 12.6 to 12.7 to this side, 13.6 by n square that side. So that may be easy. Now substitute this value here. 4 into 4 minus 1 by 2. That equal to 2 into 3, 6. I'll go with next one. So here current I in an inductor varies with the time as shown in the graph. Which of the following graph shows the induced EMF? Induced EMF formula L into di by dt minus L into di by dt. So if there is any increase in current, change in current, this will decrease because negative sign is there. Negative sign means if it is increasing, then it will decrease. So if it is decreasing condition, it will increase. Now, so check first part. Current is decreasing. So EMF need to increase. So current is decreasing means EMF need to increase or it should be constant. So change means if there is any change, then only EMF is there. Na? So that decreasing and increasing also incorrect. Next. So if there is any change, then only EMF is there. So here is the change. First part change is there. Second part just decreasing. Second part increasing. Now third part constant. Just divide this graph into 3 parts. First part decreasing. Second part increasing. Third part constant. So decreasing means so if it is decreasing, so decreasing means negative. Negative in negative. It should be EMF should be positive. Positive EMF first part. So select this one. Next, second part for this part negative EMF. So negative. After that, for third part, so EMF should be 0 on the x-axis. So that go with the fourth option. Next, a sample of radioactive element contains 2 into 10 power 16 active nuclei. Half-life of the element is 15 days. Then the number of decayed nuclei after 30 days. Half-life is 15. So 30 days means 2 half-lives. 2 half-lives means yeah, after 1 half-life n naught by 2 that becomes n naught by 2. This is after first half-life. Next, after second half-life n naught by 4. After second half-life that should be n naught by 4. So how many nuclei are there? So 2 into 10 power 6 by 4. That means 0.5 into 10 power 6 remaining. So these number of nuclei are remaining, but he is asking about number of nuclei decayed. Number of nuclei decayed. So what is the initial number? 2 into 10 power 6. So how many remaining? 0.5 into 10 power 6 are remaining. Decade means difference between these two. That equal to 1.5 into 10 power minus 6. Minus 6 or 16 plus 16. So 16. 1.5 into 10 power plus 16 will remain. So go with the third option. So if they ask about number of nuclei remaining, then go with second option. But he said that number of nuclei decayed, so that you have to take difference between final and initial number. Then you will get a number of decayed nuclei. Next. So here relation between phase difference and path reference. This one, phase difference equal to 2 pi by lambda into path reference, direct formula. Next. So in a simple harmonic motion, y equal to 5 sin 3 pi into t plus root 3 cos 3 pi into t. So multiply this one, multiply this 5, then 5 sin 3 pi into t plus 5 root 3 cos 3 pi into t. Now this is of amplitude A1, this is of amplitude A2. Here sine function is there, here cos function is there. Now what is the phase difference? 90 degrees. For sine function and cos function, phase difference is 90. Now amplitude, resultant amplitude is given by the equation A equal to A1 square plus A2 square plus 2A1 A2 cos phi. Now substitute the values here. So A1 square is how much? 5 whole square, 25. A2 square, 5 root 3 whole square, 25 into 3, 75. Plus 2 A1 A2 cos phi. Phi value is 90. Cos 90 is 0. So entire this term will be 0. So square root 75 plus 25, that equal to 100. That equal to 10. Next. So this diagram represents which type of semiconductor. So this is a Fermi level is very near to the conduction band. Now here in this one, in conduction band, dot means electrons, holes. These are holes. So electrons are there in that one. Now, so this type of semiconductor, intrinsic or p type or n type. So which one you have to select? Metal. This is not a metal because for metal, conduction band and valency band are coincides each other, or overlap each other. Conduction band, valency band overlap. So this is not a metal. So intrinsic semiconductor. So intrinsic semiconductor. So here negative charges are more, so that n type of semiconductor this one. Next. So here NOR gate, that means A plus A whole bar or A bar. Here AND gate, NAND gate, A dot A whole bar. So after that again NOR gate and NAND gate. Okay. So like that you have to substitute, then you will get A dot B whole bar. Next. To send 10% of the main current through moving coil galvanometer of resistance 45 ohms, then shunt required. Shunt resistance. That means only 10% means assume that this is a galvanometer. The shunt resistor is connected in parallel to this one. So here I is the total current, Ig is the current passing through this one. Here I minus Ig is the current passing through the shunt. Now if a shunt resistor is connected in parallel, so this is a galvanometer, this is a parallel resistance. Now this one and this one are in parallel, so potential is constant. So Ig into G equal to I minus Ig into S. So we need to calculate S only, so that S equal to Ig into G by I minus Ig. Take this Ig to denominator, G by I by Ig minus 1. What is the G value? Galvanometer resistance 45 ohms, 45 by I by Ig. Only 10% of the total current is passing through the galvanometer. Only 10% of the total current passing through the galvanometer. That means I by Ig value is how much? So 10% of total current is passing through the galvanometer. That means I by Ig value is 0.1 into I. He said that 10% of total current. That means 0.1 into total current is passing through the galvanometer. So Ig value is how much? 0.1 into I. So cancel this one. So that equal to 45 by 10 minus 1. 45 by 9. How much it is? 5 ohms. Next. So proton, deuteron, alpha particle are being accelerated by same potential difference enter into the perpendicular magnetic field. Then the ratio of their kinetic energies. Just we have to solve for kinetic energy ratio. What is the relation between kinetic energy and potential difference? Kinetic energy equal to charge into potential difference. Na? So he said that accelerated by same potential difference. So potential difference is same. Kinetic energy is directly proportional to charge. So if charge is more, then kinetic energy is more. Now proton and deuteron same charges. Alpha particle. This is Q, this is Q, this is 2Q. Or E, 2E. Now ratio is 1:1:2. Next one. A Carnot engine sink temperature is 17 degrees has a 50% efficiency. So what is the formula for efficiency? 1 minus T2 by T1. Substitute the values. 50% means 0.5 equal to 1 minus T2 value. Sink temperature 17. 17 means 273 plus 17 by T1. Now solve this one further. So 273 plus 17. How much it is? 290. 290 by T1 equal to 0.5. So T1 equal to 290 by 0.5. How much it is? 580. Okay. Next, by how much should its source temperature be changed so that increase in efficiency is 60%? New efficiency 60%. 60% equal to, that means 0.6 equal to 1 minus T2 is the same only. That means 290 by T1. We need to calculate. Again, calculate for T1. So 290 by T1 equal to 0.4. So T1 equal to 290 by 2900 by 4. How much it is? So 7 times 125. 725 Kelvin. Now, what is the increase in temperature? Final temperature is 725. Initially is 580. Now, how much is the increase? Increase in temperature equal to 725 minus 580. So 5, 4, 1. 145 Kelvin. He is asking about increasing, not final. Next one. 40 grams of argon is heated from 40 degrees Celsius to 100 degrees Celsius. Then heat absorbed at constant volume is. So here number of moles, mass by molecular mass 40 by 40, that equal to 1. Change in temperature 40 minus 60, that equal to 40 minus 100. 60 degrees, 60 degrees Celsius. That is the change in temperature. Kelvin also difference is the same only. Now he is asking about heat absorbed at constant volume. So dQ. Constant volume means NCV delta T. So N value 1, CV argon 3 by 2 R into delta T. So 3 by 2 into substitute R value and delta T value. R is 8.31. Change in temperature 60. So 9 into 80. Next one. In the circuit shown the current through 8 ohm resistor is same before and after connecting E. So if you connect this voltage, or if you are not connecting this voltage, then current is same. In the both cases, current is same. Now, so how you are going to solve this? So what is the current passing through this? Without this one, what is the current passing through this circuit? Current I equal to total voltage by total resistance 6 plus 10, 16 plus 8. How much it is? So 1824. That equal to 1 by 2 amperes. 0.5 ampere. Now, so for this potential or for this battery also current is same. Now current passing through the 8 ohm resistor equal to voltage across 8 ohm resistor into resistance value. Current passing through this one is how much? 1 by 2 or 0.5 equal to voltage across 8 ohms. You have to calculate. Resistance is 8. Now V8 equal to 0.5. So 1 minute here. So the reverse V equal to IR. So voltage across 8 ohms equal to I current into resistance value. So we need to calculate. So I value 0.5, resistance value 8. So 4 volt. 4 volt is the answer.